Aircraft production and certification is really a highly specialized activity. And why is that? It's because it's expensive. It's very expensive. So it's not a trivial undertaking. You have to be committed to it. And plus, it takes a long time. You don't certify an aircraft or you don't certify a production line and think you're going to get it done next week, Tuesday. This is something that you could measure in months and more than likely years. So it's an expensive endeavor and a time-consuming endeavor, but it results in an unmanned aircraft that meets the highest levels of safety and product reliability that the FAA has. And in fact, it's a pretty common process because it's been used by manned aviation almost since the very beginning. And there's really 3 levels of airworthiness and production certification to talk about. The first one is the design of the aircraft. So yeah, it's the parts, but it's also how the parts and every individual subcomponent acts as a whole. So that you've got an aircraft that you know is airworthy and that the government says is airworthy as well. And then there's production certification. And production certification means you can make multiple copies of that vehicle. And the FAA has said, they've looked at your factory and they've said, that's a great factory that will make safe vehicles. And then the final type of certification is a type of airworthiness that's involved with operations. So the FAA works with the manufacturer and says, these are the protocols, these are the procedures, these are the pilot checklists that need to be used to say that this is a safe operation and it's an airworthy operation. And it gives you a higher degree of assurance that risk has been mitigated, that multiple hazards have been analyzed, and that this aircraft is able to perform as it's written in the aircraft manual. And you can look up in the sky and say, that's a safe aircraft. When you take a look at aircraft certification and production certification, there's one really big issue that confronts the industry and in effect confronts the Federal Aviation Administration as well. And that's that legacy rules for manned aviation kind of dominate the entire unmanned aircraft certification process. Now, to the FAA's and industry's great credit, they're working on ways to translate manned rules to unmanned rules for certification and production. But that's kind of a work in progress right now. And I think if there's an endpoint and a vision that we're all looking to attain, it's really having an end-to-end process for unmanned aircraft certification and production certification that's only for unmanned aircraft. One of the things that we're seeing is that there's translation that goes on. So if you look at the rules for manned aircraft, there are rules for landing gear. There are rules for propellers. There are rules for pilot seat belts. There are rules for carrying manuals around. And there are rules for carrying checklists. And so certainly none of those exist in the unmanned world. And as you look at certification, both production and aircraft, you have to figure out how you find the median point between a rule that says you need something and a reality that says this isn't existing on the aircraft that I'm trying to certify under your regulations. So while the focus is certainly on commercial unmanned aircraft, there are also military unmanned aircraft. And military unmanned aircraft have a pretty extensive history going back decades. All of these military aircraft were approved under something called MIL-SPEC, military specifications. And just like the FAA says, if you're going to put a bolt in an airplane, it has to have these properties and it has to have these literally metallic elements in them. The military has done the same thing. But the civilian world and the military world, they tend to operate in parallel and they're siloed. And what manufacturers find right now is they may have an unmanned aircraft that was designed for military purposes that they want to convert to civil purposes, and yet maybe every part has met a military specification and hasn't met a commercial one. One of the things that the data we saw suggests that if there is a way to increase funding, to enhance the procedures and bring more personnel in the FAA to actually look at the military products and certify them for commercial use, we'll have the ability to get these legacy military systems into civil uses a whole lot faster. And that's something that I think is one of the industry's highest priorities right now. And there's another priority as well, and that involves spectrum management. So unmanned aircraft, they have to talk to the ground, they need to talk to each other, so air to air, and they have to use frequencies that are protected, because you certainly don't want a large unmanned aircraft being interfered with by maybe a microwave oven, anything else that generates signals. And because of that, we hear loud and clear from the industry that we need to have civil frequencies protected, and that will allow secure links for command and control, but also secure links so that when data is collected by the unmanned platforms, that it can be brought securely down to the user that's intended for, and you're not broadcasting to the entire world something that may be really critical or proprietary, or maybe something that could be subject to misuse.